Good morning, one and all. Today, we are going to discuss about the topic is random process through LTI system. In that, the problems, we are going to see the problems in LTI system. మీ వీడియో ఆఫ్ చేయండి మా Okay, see this problem. The power spectral density of a random process is given by Sxx of omega is equal to 16 divided by omega square plus 16. Find whether it is valid spectral density or not. If it is transmitted through a system as shown figure below, find the output power density spectrum. Okay. Now you see here, the given system is x of t is, it is delayed by, x of t is a random process. Now it is delayed by 2t times, and again it is delayed by, second case is minus 2t. And then you can add, you will get the y of t. So we see here the given power spectral density Sxx of omega, it is Fourier transform of a random process for autocorrelation function. It is given, the given data you write down here. Rx Sxx of omega is equal to 16 divided by omega square plus 16. And now the question is it a valid power spectral density or not? So for it is valid power spectral density or not, it should satisfy the following conditions. This Sxx of omega is means power spectral density of given autocorrelation function is must be greater than 0 for all values of for any value of omega. So if we substitute omega value, if you see this must be greater than 0. Second one is, if you see omega is reversal, frequency is a reversal, means if we test for positive frequencies as well as negative frequencies, now that value is same. Suppose if in this formula, we have a formula 16 divided by omega square plus 16. If we replace omega with minus omega, then it is a same. Whether it is a omega or minus omega, it is same. So this satisfies the two conditions, reversal of in frequency domain. So it is observed that the given power spectral density of a random process, it satisfies the both the conditions. So it is a valid power spectral density. Now from the given diagram, whatever the given block diagram, from that block diagram, y of t is equal to, one signal is a delayed by 2 times, another signal is a delayed by minus 2t times. So then these two signals are combined, are added. So y of t is equal to x of t plus tt. It is delayed by minus 2t, and x of t minus 2t, it is delayed by plus 2t. So we can add these two, and then if we apply a Fourier transform for this. We know what is the Fourier transform of y of t. It is a y of omega. According to time shifting property, the Fourier transform of x of t plus 2t, the Fourier transform of x of t plus 2t is equal to x of omega e power minus j omega 2t. Suppose it is a t naught is 2t. Suppose t naught is a plus 2t, so you can write e power j omega 2t. So the Fourier transform of x of t plus 2t is according to time shifting property. You know time shifting property, x of t minus t naught, Fourier transform is x of omega into e power minus j omega t naught. Hey, don't do like that. Why you are doing like this? Huh? Don't do the type of diagrams. Okay. Now, if we apply Fourier transform of x of t minus t naught is, you know, x of omega into e power minus j omega t naught. Here, there is a 2t, so that's why it is e power j e power j omega t naught. Instead of t naught, we have 2t here. And similarly, instead of t naught, we have here minus 2t. So, e power minus j omega 2t into x of omega. Now here, x of omega is a common factor here. So if we take x of omega as a common factor, now you can write e power j omega into 2t or e power j 2t into omega plus e power minus j 2t into omega. Now if you write y of omega, this x of omega, you take left side, y of omega by x of omega, it is equal to h of omega. It is nothing but transfer function of the system. So if we see this one, e power j omega plus e power minus j omega by 2, it is nothing but cos signal. So you can multiply 2 with numerator and denominator. So whatever the e power j omega plus e power minus j omega by 2, it is a cos omega. Here instead of omega, we have here 2t omega. So 2 into cos of 2 omega t. It is the transfer function of the system. Now, if we want to calculate output, that output means sy y of omega. This sy y of omega already we know. For an LTI system, the input is for an LTI system, the input is x of t. The formula between transfer function and output is magnitude of h of omega whole square into sxx of omega. Here sy of omega is power spectral density of the output. Sxx of omega is power spectral density of the input. H of omega, magnitude of h of omega whole square is transfer function of the given LTI system. So we have calculated just now, we have calculated the transfer function of the given LTI system, that is a 2 cos of 2 omega t. So you can apply square for this. So 2 square is a 4 cos square of 2 omega t into sxx of omega already given in the problem, that is 16 by omega square plus 16. So finally, this sy of omega is equal to Sy of omega is equal to, you can multiply here 16 into 4, 64 cos square of 2 omega t by omega square plus 16. So it is the given problem. We have calculated this S by y of omega. So simply here the idea is, he has given, again I am repeating, he has given the power spectral density of the input of autocorrelation function, and he has given a block diagram. Simply here we are delaying with 2t and delaying with minus 2t, and we are going to be added. So if you have idea about Fourier transform, it is going to be obtained easily. It is about the given problem. You see the next problem. A stationary random process x of t and y of t has spectral density functions, that is a sxx of omega is equal to 16 divided by omega square plus 16. So again, what is this sxx of omega? It is a power spectral density of given random process. So what is the power spectral density? Fourier transform of autocorrelation function of random process. So, and Sy of omega. Sy of omega means power spectral density of output of the system. So what is the Sy of omega means? Fourier transform of autocorrelation function of output. So what is the, whenever the autocorrelation function is input, then the output is a Ryy of tau. So if you apply Fourier transform for Ryy of tau, it is going to be get Syy of omega. This Sy of omega is power spectral density. Okay, it is equal to omega square by omega square plus 16. Another stationary random process, you can consider u of t is equal to sum of x of t plus y of t. Here x of t is a one random process, y of t is a another random process, and then these two are going to be added, that is u of t. Find the spectral densities SUU of omega and SXY of omega, SXU of omega, and SYU of omega. Assume that x of t and y of t are uncorrelated with zero mean value. So whenever it is uncorrelated, means if we calculate the cross correlation, the cross correlation function is 0 and mean value is also 0. Okay, it is the given problem, and you see whatever the given data, you write down this given data here. Sxx of omega is equal to 16 divided by omega square plus 16. Sy of omega is equal to omega square by omega square plus 16. So u of t, as given the u of t is equal to x of t plus y of t. If you apply Fourier transform for this, what is the Fourier transform of u of t? It is not going to be applied directly on the random process. So you need to calculate corresponding autocorrelation function. So what is the autocorrelation function of u of t? That is nothing but RUU of tau. So RUU indicates that autocorrelation function. If you apply Fourier transform for RUU of tau, so you will get SUU of omega. Okay, so it is right. The autocorrelation function of RUU of tau is equal to expected value of u of t into u of t plus tau. Expected value of u of t into u of t plus tau. Already you know what is the u of t. He has given in the problem x of t plus y of t. And what is the u of t plus tau? X of t plus tau, x of t plus tau plus y of t plus tau. So you multiply these two terms, and finally you can apply this expected concept on this after multiplication. If you see, if you multiply these two, you will get x of t into x of t plus tau. Okay, x of t into x of t plus tau. It is the expected value of x of t into x of t plus tau. And then you observe this one here, x of t into y of t plus tau, y of t into x of t plus tau, and y of t into y of t plus tau after multiplying this one. And then if you apply this expected operation on these individual terms, After applying this expected concept, it is going to be, what is this one? Expected value of x of t into x of t plus tau is nothing but autocorrelation function. Next, y of t into y of t plus tau, it is also a x of t into y of t plus tau, it is a cross correlation function. Now, y of t into x of t plus tau, it is also cross correlation. So, cross correlation means two different signals, two different random process. Here, x of t is a one random process, y of t is another random process. So, rx y of tau plus ryx of tau. Now, y of t into y of t plus tau, again it is a autocorrelation function, ryy of tau. So, it is the autocorrelation function of output, autocorrelation function of output. Now, if you apply Fourier transform for this, we apply Fourier transform. So, Fourier transform of r uu of tau is equal to s uu of omega is equal to Fourier transform of rxx of tau is sxx of omega plus Fourier transform of rxy of tau is equal to sxy of omega plus Fourier transform of ryx of tau is equal to syx of omega plus Fourier transform of ryy of tau is equal to syy of omega. So, if you apply Fourier transform for whether it is an autocorrelation function or it is a cross correlation function, you are going to be get corresponding spectral density. Okay. Now, he has given the clue. What is the clue as given here in the problem? X of t and y of t are uncorrelated and zero and have the zero mean value So from that you can write this sxy of omega means this one. We have already formula sxy of omega. Previously in the properties also we have derived this one. sxy of omega is equal to syx of omega is equal to delta of omega into x bar into y bar. What is the x bar here? Expected value of x of t. What is the y bar here? Expected value of the y of t. What is the delta of omega? It is going to be exist at omega equal to 0. Now, he has given in the problem, it has 0 mean. So, whenever x bar is equal to 0 and y bar is equal to 0 and corresponding sxy of omega and syx of omega is going to be get 0. And then finally, if you see s uu of omega, su of omega is equal to 16 divided by omega square plus 16. That is the sxx of omega, and based on the previous whatever we have assumption sxy of omega and syx of omega from the given data, it is not assumption, from the given data these two terms are 0, and then syy of omega is equal to omega square by omega square plus 16, and here you take LCM for this. So denominator terms are same, just numerator terms you can add. So omega square plus 16. So omega square plus 16 numerator and denominator also omega square plus 16. So if these two are gets cancelled, you will get 1. So whenever it is a 1, yes, uu of omega is a 1, then you can coming for, he has asked the sxy of sxu of omega. Sxu of omega. What is the sxu of omega? The Fourier transform. You need to find out first cross correlation between x and the output u of t. He has given the output is a u of t. So you can write Fourier transform of rxu, rxy u. It is not omega. Here it is a tau. He has given mistake here. This sxu of omega is equal to Fourier transform of rxu of tau. So first of all, you need to calculate autocorrelation function. You need to calculate autocorrelation function. Sorry, you need to calculate cross correlation function between x and u. So it is not omega, again I am repeating, it is a tau. There is a print mistake. So whenever if you want to calculate cross correlation between this x of t and this u of t. So we know the formula of cross correlation, expected value of x of t into u of t plus tau. Expected value of x of t into e of t plus tau. Now we substitute that x of t as it is, u of t plus tau, you has given u of t is equal to x of t plus y of t. So you substitute here x instead of t, you substitute here t plus tau. You substitute here t plus tau. Already we know what is the u of t. U of t is equal to x of t plus y of t. So instead of t, you substitute t plus tau. So u of t plus tau is equal to x of t plus tau plus y of t plus tau. Okay, you substitute that data here, and then you multiply, and then you multiply these two terms. If you multiply, you will get x of t into x of t plus tau plus x of t into y of t plus tau. You know, if we apply this expected operation on both the terms, we have here two terms. So expected value of x of t into x of t plus tau, you can get rxx of tau, autocorrelation function between x of t autocorrelation function between x of tau. ఏ ఎవరు ఈ విధంగా చేస్తుంది? తీసే అరేంజ్ చేయరా? ఏ అవి అరేంజ్ చేయండి అవి. Now this expected value of x of t into x of t plus tau is nothing but autocorrelation function. So that is going to be right rxx of tau here. Next, expected value of x of t into y of t plus tau. It is the cross correlation between x of t and y of t. So it is rxx of tau. It is rxy of tau. Okay. If you apply Fourier transform, if you apply Fourier transform. 1 second. All of you keep your roll number on your display name. All of you, I will take attendance. For that, I require keep your roll number on your display name. Keep your roll number. Change your DP. All of you keep your roll number. We need attendance. All of you keep your roll number. Change your name with your roll number. Change your name with your roll number. Change your name with roll number. Are you getting? మీ రోల్ నంబర్ పెట్టండి. వినబడుతుంది అందరికీ? I need attendance. సరేలే. సరేలే. సరే సరే. హలో హలో.
ఎస్ సార్.
మా ఎవరున్నారు క్లాసులో నాకు తెలిసిన వాళ్ళు? శ్రీవిద్య, శ్రీవిద్య ఉన్నావా? మా ఇప్పుడు పలికినమ్మా ఎవరు?
సార్ డి సెక్షన్ సార్.
ఏం పేరు?
లెటర్ ఎంట్రీ 4 నిఖిత సార్. లెటర్ ఎంట్రీ 401.
403. పాప కొంచెం స్క్రీన్ షాట్ చేయనా ఈ నంబర్లా?
401 సార్.
అవి కాదు నాన్న, ఇప్పుడు ఎవరైతే క్లాస్ లో ఉన్నారో
సార్ యాడ్ కావట్లేదు. ఓకే సార్, ఓకే సార్, తీసి పెడతాను సార్. మేము క్లాస్ జాయిన్ అవ్వడానికి కావట్లేదు సార్. ఎందుకు కాలేదు? 100 మెంబర్స్ లిమిట్ అయిపోయింది సార్. చూపిస్తుంది సార్.
100 కన్నా ఎక్కువ జాయిన్ కాకూడదా? ఇదేం కనుక్కుంటా అయితే. ప్రస్తుతానికి ఉన్న వాళ్ళని స్క్రీన్ షాట్ తినన్నా. వేరేదేమన్నా గూగుల్ నెక్స్ట్ క్లాస్ గూగుల్ దన్నా పెడతా. తీసావా? ఈ విధంగా గీసేవాళ్ళు ఎవరు? ఏంది ఇది క్లాస్ అయింది పాప? 403 స్క్రీన్ షాట్ తీసానా? కాదా, స్క్రీన్ షాట్లు తినే పాప.
సార్ తీస్తానా సార్? తీస్తానా సార్?
ఇది రికార్డ్ అవుతుంది ఆర్కెస్ట్.